Okay, so now we're going to go the other way. So we're going to have like b to the y equaling x, but we're going to change it into a logarithmic function or a logarithm form. So remember, these are equations. Okay, so you're going to write log, then you're going to put the little subscript b. That's got to be a subscript. Students make a lot of mistakes with that. And then you can't just have log and a base. You have to have it of something. You have to have what's called the argument. There has to be something there. Okay, that's another mistake I see for students. So in this case, we're going to start with the base. We go across and pick up the argument. That's going to be x. I'm going to put it in parentheses. You'll see why. And then equals the exponent. Remember, a logarithm equals the exponent. Okay, so here we go. We're going to take the 12. That's going to be our base. So that's the subscript. We're going to go across here and pick up the argument. And then it's going to equal that exponent, 2. So now we've taken it from exponential form and written it in logarithmic form. Remember, these are equations. Okay, so the next one, log, the base is b, so subscript there. The argument is 8. You're going across here, getting the 8, and it's going to equal the exponent, which is 3. Okay, so these are in logarithmic form. All right, now we're going to take this one and we're going to write log base e, there's the base, of 9 equals y. Now, when the base is e, that's special. We'll get to that in this section, but not right now. Okay, so that's how it works. You do a couple of them and hopefully it's not too bad. Okay, now it says in the directions to evaluate by inspection. For me, I usually just write it in the exponential form when I'm wanting to evaluate a logarithm. Now to do that, you can say, well, this isn't an equation. Yeah, but I could make it an equation. So what I'm going to do is say, hey, this value, log base 2 of 16, it equals something. I don't know what. That's what I'm trying to figure out. Then I can write it in exponential form. So I'm going to say 2 to some exponent, that's what I don't know, equals 16. So I just set it equal to x or whatever variable you like, and then I write it in exponential form. That's a little bit easier for me to see. Now when I think, hey, 2 to what equals 16? Let me think about that. Well, I think it's 4, right? Because that's, if I go 2 to the 4th power, that's 16. I've seen that several times. So when we're trying to evaluate this, we're saying that equals 4. Okay? We don't really get to make equations just because we feel like it. But what we're doing is we're solving for that variable, and then that's what the expression equals. Okay. Now, in the textbook, they have this problem. They write it this way in the textbook. But for me, I think that looks a little confusing. It might not to you. You might like it better that way. Great, because I don't have any control over changing the textbook. But I like to put the argument in parentheses. I think it just makes it a little clearer, but that might just be my preference. I'm not going to mark it wrong, but you do want to be clear on what's the base, what's the argument. Okay, I'm going to keep using that word argument because I want you to get used to it. Okay? All right, so we're saying, hey, 7 to some power, you can put a question mark if you don't want to make it an equation, is going to equal 1 over 49. Now, you know the relationship between 7 and 49, right? 7 squared is 49, so hopefully that's not a big surprise. But how do you get it to be 1 over 49? Well, you have to have a negative exponent, right, to get it in the denominator. So this is going to equal negative 2. See, 7, that's the answer. 7 to the negative 2 power is 1 over 7 squared, which is 1 over 49. That's what we're trying to find, okay? All right, so that exponent that we needed, that I had this question mark on, what was it, question mark, was negative 2. That means this expression here evaluates to be negative 2. Okay, let's try again. We'll go back to my old method, setting it equal to x. So 25 to some exponent equals 5. Again, this is the base. This is what we're taking the exponent to. Like base to an exponent, right? And we want it to equal 5. How do you get 25 to some power to equal 5? Now you know the relationship between 5 and 25. 5 squared is 25, right? So what we really want is we want to take the square root of 25 to equal 5. But we can write that as 25 to the 1/2 power. That's true. Okay, so what was the exponent? What was the x? What were we trying to get? We said it equals 1/2. Okay? So they call this doing these by inspection. I'm trying to give you a little more information how to approach it, but it's not necessarily easy. Okay. Next one might be a little bit easier. We'll see if you like it. So you have this logarithm that you're trying to evaluate, and it equals something, say x. Well, then if you write it in exponential form, it's 2, there's the base, to the exponent, you go over here and get the exponent, equals the 5th root of 2. It equals the argument right there, okay? Well, what's the 5th root of 2? Couldn't you write that as 2 to the 1/5 power with a rational exponent? And the answer is yes, that's why we did that, so that's important. Now, here's your base 2, right? Here's a base 2. So if these are going to be equal to each other, doesn't x have to be 1/5? So that means this whole expression evaluates to be 1/5. Okay? So that's a little bit of practice. We'll do more later.